all are ready? This is the first class for 11th standard or +1 students. All of you have notebook with you. You may write running notes. Okay, our first unit is, you can see here, the physical world and measurement. The first topic we are going to discuss here, in the basic concept of physics, is about force. Already you studied about force in 9th standard, isn't it? I think the definition you learned in 9th standard was like this. Force is something which can change the state of rest of a body into motion, motion into rest. It can increase the speed, decrease the speed, or it can change the direction, or it can change the shape of a body. So force is something which can do all this work. In this lesson, we are going to discuss about the fundamental forces in nature. So the first topic is about the fundamental forces in nature. We have 4 fundamental forces in nature. You can see here, these are the 4 fundamental forces in nature. The first one is, it is familiar to you, gravitational force. This you studied in 9th standard. So what all things you learn in 9th standard, that will be repeated in 11th. And what all things you learn in 10th standard, that will come in 12th also. Okay. Now, the most of the lessons in 11th is related to 9th class portions. Now, the first fundamental force in nature is gravitational force. You know Newton's law of gravitation. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And we got an equation in that F is equal to G m1 m2 by r square. So that G is a constant of proportionality. You remember the name of that? It is universal gravitational constant. Its magnitude is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So all of you refresh your memories. All the concepts you learned in 9th standard is needed in this year. Now, the second force is weak nuclear force. You are not familiar with that one. I will explain in detail. And the third one is electromagnetic force. That also some concepts you know about that from 10th standard. Electromagnetic induction. Electromagnetic induction you learned in 10th standard. Faraday's law of electromagnetic induction. It is related to that. And the fourth one is strong nuclear force. In strong nuclear force also some concept you learn in 10th standard. That is in source of energy. In that nuclear energy is coming fission, fusion, reaction and all. So we'll come to that. Means these are the 4 fundamental forces in nature. The first one is gravitational force, then weak nuclear force, second is electromagnetic force, and third one is strong nuclear force. And these forces are arranged in the 1, 2, 3, 4. It is arranged in the increasing order. Increasing order means the weakest force is gravitational force among these. So among these forces, the gravitational force is the weakest one. Then stronger one is the weak nuclear force. Then electromagnetic force. The strongest force in nature is strong nuclear force. We will come to this one by one. We will discuss about gravitational force. All of you know what is gravitational force. What is gravitational force? Some students used to answer this question. It is the force due to the earth. It is the force of attraction of the earth. There is a wrong concept among students. Gravitational force means it is the force of attraction of the earth. Actually, gravitational force is one of the examples for gravitational force. Actually, gravitational force exists between any 2 bodies in the universe. Even if you 2 friends are sitting nearby, there is a force of attraction among you. But you cannot feel that force. The reason is there. 2 girls sitting nearby or 2 boys sitting near. If you want to find the force between you, you can use the equation you studied in 9th standard. F is equal to G m1 m2 by r square. In that equation, F is equal to G m1 m2 by r square. If you apply the value of your mass, okay, first the mass of the first one, the second one, divided by distance square r square, into G is coming there. G into m1 m2 by r square. The G value is 6.67 into 10 raised minus 11. It is 10 raised minus 11. Minus 11 means 0.00011% will come. Okay, decimal will be at the left side, 0.0011%. So such a very small number, 0.000 with 11 positions of decimal Then you multiply with your mass and the next mass of the other one and divide by the square of the distance. You will get a force very, very small, nearly zero. You cannot feel it. But you can feel it if your mass is just like the mass of Earth. Suppose you are growing in size, and one day you are become like moon, and other girl become like Earth. Then if you multiply the mass of m1, m2 and divide by the square, then you will feel the force. Right now you cannot feel the force of gravity among you because your mass is very small. But still the force of gravity is existing. So actually gravitational force, you can see here, gravitational force, the definition of gravitational force is this one. All of you can write down in your class notebook. The definition of gravitational force is this one. It is the force of attraction between any two bodies, by virtue of mass. It is the force of attraction between any two bodies by virtue of mass. So every object in the universe attract each other. Not only Earth and Moon, not only Earth and apple. Two apples also attract each other. Okay? If mass is there will be gravitational force. Any two bodies, every object in the universe attract each other with a force F that is proportional to product of their masses m1 and m2 and inversely proportional to square of the distance between them, 1 by r square. Okay, now we will see the basic properties of gravitational forces. You can see here on the screen, the first one is it is always attractive. The gravitational force is always attractive. Attractive means in gravitational force between two bodies there is only force of attraction, there is no repulsion. But if you take other forces like electromagnetic force or the force between two charges, positive and positive will repel and positive and negative will attract. If you take two magnets, north and south will attract, but north and north will repel. Like poles and unlike poles attracts each other. But in gravitational force there is only force of attraction, there is no repulsion. So the first property, you can note down, the first property of gravitational force, it is always attractive. The second property is that it is the weakest force in nature. Among the, I told you in the beginning, among the four forces, fundamental forces, this gravitational force is the weakest force in nature. And all other force we compare with the gravitational force. We will see afterwards. The third property is it has infinite range. The range of attraction of gravitational force is infinity. Infinity means we can see the gravitational force exists. The gravitational force exists between the Earth and Sun. And you know the distance between Earth and Sun. Okay, it is 8.3 light minutes. The distance is equal to the distance traveled by light in 8.3 minutes. In 1 second, light travels 3 lakhs kilometer. Then you can calculate for 8.3 minutes into 60 into 3 lakhs kilometer. It's a very huge distance. In that distance also, gravitational force between the Sun and the Earth exists. That is why Earth is revolving around the Sun. If that gravitational force is disappearing, then the Earth will be moving along the tangent to the orbital and it will be colliding with other planets and all. That will be end of the world. So since the gravitational force between the Sun and the Earth is existing, that is why the Earth is revolving around the Sun. The same way, the gravitational force between Moon and the Earth is existing, that is why Moon is revolving around the Earth. If the gravitational force between the Moon and the Earth is disappearing, the Moon will be thrown out of that orbit along the tangent. Got it? So we can say it is having infinite range, the range of attraction. It won't stop. The gravitational force, we cannot say after 2 meters it disappears. No, it will continue. It has infinite range. The fourth property, it is a conservative force. The fourth property, it is a conservative force. So the word conservative force, it is new word for you. Conservative force means, if you are doing work by using a force, and if that work done, if it depends on only the initial and final position, if it does not depend on the path taken, if it depends only on the initial and final position, that is called conservative force. For example, gravitational force is a conservative force. Suppose you see from here. See in this diagram, suppose this is a wooden block. Okay. Right now it is lying on the surface, ground surface. And from this point, suppose I am lifting this wooden block from the ground surface to a height. say to a height h, means I am lifting to this point. Now you know how much is the work done here. The work done will be equal to, you studied in 9th standard, work done will be equal to W is equal to force here. Force will be equal to the weight applied. The weight of this wooden block, if m is the mass of this wooden block, the weight will be acting downward. The weight will be mg. Mg will be acting downward. So if you want to lift it upward, you have to apply a force in the upward direction that is equal to mg. Mg should be applied in the upward direction. So F is equal to mg is the force applied in the upward direction. And you are lifting a distance, total height, suppose this height is equal to h. H is the height from the ground till here. Then the work done is equal to force into displacement. Force is mg. Mg is the force applied upward direction equal to weight of the body into height. H is the displacement. Mgh is the work done. Okay. Now see the same body, suppose the same body, instead of lifting straight like this, suppose you are lifting from the ground to a height this much, okay, to this much height, say that is h1 to here. Then you are moving that body in this direction horizontally, some distance to this point. Again you are lifting to the same previous level, means same this level. Finally it reaches the same height of the first case. Suppose I am taking this initial height, this is the ground level. Suppose I am taking the initial height lifted from the ground level is h1. This is h1. And here there is no change in height. And this is h2. So that h1 plus h2, that is the two heights total, means these two height, this h1 plus this h2, this h1 plus this h2 is equal to this height, same height of the first case. Same height of the first case. Okay. Now when we calculate the work done in this case, the first step when I am lifting from this point to this point, the work done W1 I am taking. W1 is equal to mg is the weight and h1 is the height. h1, mg h1. And when I am moving from this point, from this point to here we are moving this direction, but the gravitational force is acting downward. We are calculating the work done against the gravity. So gravitational force is acting downward and the displacement is this way. And you remember in 9th standard you studied, if theta equal to 90 degree, work done will be 0. If theta is 90 degree, if the angle between the direction of displacement and direction of force is 90 degree, work done will be 0. So in the second case, work done is 0. W2 is equal to 0. And in the third case here, when I am lifting from this point to here, the work done is W3. That will be equal to mg into h2. Mg into h2. So the total work done in this process is the W1 plus W2 plus W3. That is the total work done. I can write W is equal to W1 is mgh1 plus 0 W2 plus mgh2, that is W3. Okay. This is equal to mgh1 mgh2. Mg I can take common factor outside, mg, and inside bracket h1 plus h2. You know this h1 plus h2? This h1 plus h2 is equal to h, that is this height, is equal to mgh. Okay. So what does it mean? See the first case, when you lift the body in the gravitational force field directly in a straight line, you got mgh. The second case, you lifted this much, then moved horizontally, then again lifted, and the final position is same. Then also the total work done is mg. Both are equal. So in a gravitational force field, if you take a body directly from one point to the height, or if you take in one direction then go another way, and finally to the same point, the total work done depends only on the initial and final position. In between, the path is independent. If you go straight, if you go in a curved way, or if you take like this and make many circle and go to the same height, doesn't matter. Work done depends only on the initial and final position, the straight line distance only. Such a force which does not depend on the path taken, the work done by the force does not depend on the path taken, is called conservative force. Suppose you are dragging a chair from one point to the another point straight, you have to do some work against the friction. The same chair, if you are taking from the first point to the last point, not in a straight line, if you take a curved path, okay, then come back to the point, you have to do more work. It means In frictional force, the work done depends on the path taken. And such forces are called non-conservative force. Non-conservative. And we'll discuss in detail about conservative force and non-conservative force in the coming lesson. Okay. So here right now you have to note down this gravitational force is a conservative force. It means the work done by the gravity does not depend on the path taken. Okay. And the last one is it is a central force. It is a central force. A central force means suppose this is Earth. Okay. This one is Earth and this is an apple. There is a gravitational force existing between the Earth and the apple, and that force will be acting along the line joining the center of the Earth and the center of the apple. That is why when the apple is falling down, it falls like this, straight this way. The reason is that the force between these two, the force between the apple and the Earth is acting, the line joining the center of the apple to the center of the Earth. So this gravitational force acts along the straight line joining the center of the apple to the center of the Earth. And such forces are called central force. And gravitational force is a central force also. If the force is acting this way, then if you drop something, it will be falling like this. When you drop something from your, suppose if I am dropping this pen, it is falling vertically downward because the force between this pen and the Earth is acting center of this pen and center of the Earth. That's why it is falling vertically down. Otherwise, if the force is acting this way or this way, if I drop, then it will go this way or it should go this way. Because you know from Newton's second law in 9th standard, okay, the rate of change of momentum is directly proportional to the force, and the change in momentum will take place in the direction of force. Change in momentum will take place in the direction of force means change in momentum means mv minus mu. So that mv, v, velocity direction, while falling down, the velocity direction will be in the direction of force. So always motion will be in the direction of resultant force acting on a body. It means when an apple is falling down, it is moving vertically downward because the force between the apple and the Earth is acting along the line joining the center of the apple and center of the Earth. It means it is a central. These are the basic properties of gravitational force. Now we can have a short journey from this position, from right now your position, you can locate your position in GPS. From that point you will have a journey, a short trip. This is your GPS location. From here we'll start flying. We'll fly out of the Earth and even out of the galaxy, out of the Milky Way galaxy. Okay, start. You are out of the Earth. Now you cross the atmosphere, so it is dark now. Even if it is daytime, there is no light, we cannot see any light in the surroundings because of no scattering of light. But we can see other planets. We are crossing the planets and we are moving very fast. Yes. We are crossing different planets. Saturn, enjoy the journey. Different comets, different asteroids, many things are crossing us. Outside the galaxy, our Milky Way galaxy. This is our galaxy. There are millions of stars in this. We don't know how many are there. And our Earth is a small dot, less than a dust particle in this galaxy. And we human beings are nothing. This entire universe is existing like this because of gravitational force. The gravitational force is the force binding this galaxy, this universe, as a single unit. And this gravitational force, it is not the force of Newton. It is the force of the Almighty, the Creator. Newton just explained to us about the gravitational force. And the gravitational force exists before Newton and after Newton. And this entire universe is existing because of that gravitational force. Now see the galaxy, how beautiful it is. We are outside it. Now we are looking to our galaxy Milky Way from outside the galaxy. It is a great experience. And see the universe and its creation. Okay, that is great, isn't it? That is our universe. Now we will discuss about the second one, the second fundamental force, that is weak nuclear force. This is one. The second one, weak nuclear force. The properties of weak nuclear force, it is stronger than gravitational force by 10 raised 25 times. 10 raised 25 means a number with the 25 zeros. You have to multiply gravitational force with that much value. Means it is very high, and it is a very short ranged force. Very short ranged force means its range of attraction is very less. It is 10 raised to minus 16 meter. Its range is 10 raised to minus 16. Means this force will exist only in 10 raised to minus 16 meter, and it is not a central force, and it is not a conservative force. It is not a central force. It is not a conservative force. Now, what is actually weak nuclear force? So weak nuclear force, it is related to nuclear physics. And you are not familiar with the nuclear physics, so I will try to explain some points about the nuclear physics. You know the structure of atom. Inside the atom, at the center nucleus, we have two fundamental particles, that is protons and neutrons. Okay? And electrons are revolving outside. Electrons are revolving outside in circular orbits. Negative charge electrons are revolving outside in circular orbits, and protons are positive charge, and neutron has no charges. Now you know about radioactivity. The atoms like uranium, thorium, protactinium, okay, tellurium. These are the heavy metals which are highly unstable. They will keep on radiating alpha, beta, gamma radiations. And this phenomena in which an atom give out alpha, beta, gamma radiation, that phenomena is called radioactivity. In detail about radioactivity we will be studying in next year in 12th standard. We have a lesson for nuclear physics. Now right now we need only short explanation only, so I'll explain in brief what is weak nuclear force. So during radioactivity there are two particles emitted from a radioactive element like uranium. The one particle is alpha particle, and that alpha particles are positively charged particle. They have mass 4 times the mass of proton, or 4 mass, we can say like 4 mass, and it has charge 2. So 2 charges of, means an alpha particle consists of 2 protons and 2 neutrons, that is coming out of the nucleus during radioactive disintegration. An alpha particle consists of 2 protons and 2 neutrons, so it has a mass 4 and charge 2 plus 2. Then beta particle, that also coming from the nucleus. That beta particle, there are two types of beta particle, negative beta particle and positive beta particle. We'll talk about negative beta particle. Negative beta particles, they are nothing but electron. They are also coming from the nucleus. And we studied in lower classes, electrons are revolving outside the nucleus, isn't it? But during beta decay, electrons are ejected from the nucleus also. How it is possible? Inside the nucleus there are only proton and neutron. But during radioactive disintegration from a uranium or thorium, protactinium atoms, electrons are emitted, beta particles are emitted. Beta particles are nothing but electron. Negative charge, and the magnitude of charge is 1.6 into 10 raised minus 19 coulomb. They are nothing but electron. And they are coming from the nucleus. How is it possible? So what happens during the beta decay? Inside the nucleus, one neutron inside the nucleus will be split into one proton, one positive charged proton, and one electron, that is called beta particle. That one electron form is ejected in the form of beta particle, and one particle called antineutrino. It's called antineutrino. This is antineutrino. This is what happening during beta disintegration. One neutron split into one proton, one electron, and one more particle called antineutrino. This antineutrino is a chargeless, massless particle. It is a chargeless, massless particle. When we are saying massless particle, it doesn't mean its mass is zero. We used to say zero mass, massless particle, because its mass is very, very small. If mass is not there, we cannot say there is particle existing, isn't it? If there is a particle, it should have a mass. So it has mass, but it is very, very less than electron. The mass of electron is nearly 1 by 2000 the mass of one proton. If you divide the proton mass into 2000 equal parts, only one part is the mass of an electron. And for antineutrino, its mass is less than that. It is very, very negligible. So we say it has no mass, but it has mass. And we can detect that neutrino in an experiment by cloud chamber experiment. I will show you that. We can detect, even if its mass is very less, it cannot be seen through microscope, okay, with powerful microscope also, but we can see the presence of antineutrino in a cloud chamber experiment that I will show to you. So before that, when these beta particles are emitted from a nucleus, splitting of one neutron into one proton, one electron, and one antineutrino, there is a force existing. Between this electron. This electron formed during the splitting of neutron is nothing but beta particle, and during beta emission, there is a force existing between this beta particle and this antineutrino. Between these two, there is a force of attraction. That force is called what? Weak nuclear force. That force is called a weak nuclear force. It is stronger than gravitational force by 10 raised to 25 times, and it is very short range force. Its range is 10 raised to minus 16 meter only, 10 raised to minus 16 meter, or you can say 10 raised to minus 13 millimeter. Means if you divide 1 millimeter by a number with the denominator with the 13 zeros, 1 millimeter in your scale, the small line, that you divide by a number with the 13 zeros. 1 millimeter divided by a number with the 13 zeros. Out of that, one part. That is the range of attraction between beta particle and antineutrino. So it is called a short ranged force, and it is stronger than gravitational force by 25 times. Now we can see how can we detect this particle, antineutrino, whether it is existing or not. We can see. Can you see this one? It's a beautiful sky. You might have observed this in your day-to-day life. If there is a jet flight moving in sky, okay, in the atmosphere, you can see a tail forming here, a white cloud tail. And most of the people are having a wrong concept is that this is what is the smoke ejected by the jet plane. It is not smoke. It is the cloud formed. Because of the speed of the jet flight. You know how? It is according to Bernoulli's theorem. Again, that Bernoulli's theorem is coming this year in properties of bulk matter. I will explain Bernoulli's theorem in short. Bernoulli's theorem, this is the basic principle. When a body moves through a medium can be air or water, any medium. When a body moves through a medium, when the speed increases, pressure in that area will decrease, inversely. When the speed of the body increase in that region, the path of the movement of the particle or the path of the movement of the body, when speed increases in that region, pressure will decrease. When pressure decrease, air will expand into that area. When air expand, it will cool down. When air cool down, already in the upper atmosphere, already the air is saturated with the water vapor. So what happens here, when the jet flight is moving very fast, with very high speed, 2 Mach, 3 Mach speed, 3 times, 4 times the speed of sound, very high speed. The path of this jet flight, pressure will be very less because speed is very high. When pressure is very less, the air in that area will expand. When air expands, always it will cool down. When it cool down, it will become super saturated. It means it will form cloud. This is what we can see in the sky if there is a jet flight moving in the sky. You might have observed, isn't it? This principle is used in cloud chamber experiment to see minute particle. If there is minute particle like antineutrino moving in a space, and we cannot detect it with our eye or microscope, we will make a cloud area with a highly supersaturated water vapor, with a lot of water vapor in that area. And if radioactive decay is going on inside that, and if it is producing minute particle, when this particle moves through that water vapor, if there is a lot of water vapor, and due to the speed of the small tiny particle, it will produce a small track. It will produce a track of the particle with a low pressure. In that area it will form small clouds, and from that cloud we can see the experiment. This is the cloud chamber. Inside there is more water vapor and some radioactive materials are placed inside. Now we can see clouds are formed at different points. Yeah, here there is one cloud. This is another cloud formed. These are showing the track of invisible tiny particles, antineutrino, produced during the beta disintegration. Otherwise we cannot see it. It is just like the track formed by a jet plane. Same like that, here you can see many tracks are formed at different points, at different locations. Now our discussion is here in weak nuclear force. It is the short range force. It is stronger than gravitational force by 10⁻25 times, and it is very short range force, and it is existing between beta particles and antineutrino produced in radioactive disintegration. And we have two more forces, that is electromagnetic force and strong nuclear force. We'll discuss about these two forces in next class. Okay.